In today's lesson, we are going to learn about some basic trig identities. A trig identity is basically a true statement involving trig functions. And then we're going to work through, they're kind of like proofs. We're going to have a complicated statement, and we have to prove that it's true. Trig identities, they're endless, and we could learn so many of them, but we're just going to stick to kind of the basic, most popular ones for today. The reciprocal identities and quotient identities you already know. So reciprocal identities is just showing that sine of theta is equal to 1 over cosecant of theta, and then cosecant of theta is equal to 1 over sine theta. And then cosine is 1 over secant, and then secant can be written as 1 over cosine. Tangent, 1 over cotangent, and then cotangent, 1 over tangent. So it's just showing different ways that you can write trig functions using those reciprocals. The quotient identities you also already know. So that would be knowing that tangent is sine over cosine, and that cotangent is cosine over sine. So far all this is just understanding that you can write trig functions in multiple ways. Okay, and now the Pythagorean identities are new, and here's the most popular one, is that sine squared of theta plus cosine squared of theta equals 1. You can also rearrange this identity in different ways. You can just rearrange the identities. You could say cosine squared equals 1 minus sine squared, or sine squared equals 1 minus cosine squared. Another one is secant squared minus tangent squared also equals 1. And you can rearrange that identity to get these other two. And there's one more. Cosecant squared minus cotangent squared also equals 1. And again, you can rearrange that identity 2 other ways. So we are now going to use these trig identities, and then we're going to verify these trig statements using these identities. All right, so now I have this statement that tangent squared times cosine squared plus cotangent squared times sine squared equals 1. So the idea is, like your identities up here, you would memorize. This is not something you memorize, it's something that you prove using what you would have to memorize. So the idea is we are using the identities to rewrite this to prove that the left side equals 1. When you're doing this, you only want to rearrange one side. You're going to change one side and make it equal to the other side. Sometimes you don't know where to start and you just want to pick what you see and see if you can rewrite it a different way. And sometimes you can figure it out in 2 steps. Someone else might figure it out, but they might use 6 steps. So there's all different ways that you can use these. So let's think. Tangent squared. If I look here, well, I have tangent squared equals secant squared minus 1, but I also have that tangent equals sine over cosine. So tangent squared would also equal sine squared over cosine squared. So I'm going to actually try that one. I'm going to try this. So I'm going to rewrite tangent as sine squared over cosine squared, and then times cosine squared, plus, how can I rewrite cotangent squared? Same thing. I could rewrite cotangent squared as cosine squared over sine squared, and I'm multiplying by sine squared. So all I did was I rewrote this and I rewrote this using a trig identity. And now see if I can simplify. Well, here, those will cancel and those will cancel. And then what comes down, sine squared theta plus cosine squared theta equals 1. And wait, that is a trig identity. This equals 1 and 1 equals 1. You're just rearranging your trig functions to prove a statement. All right, here we have another one to prove. We're verifying this trig identity. They're not always equal to 1, just the first two examples happen to be. So we have to rearrange that left side to prove that it equals 1. Well, let's look at the chart. Oh, wait, 1 minus cosine squared could be rewritten as sine squared. So this could turn into just sine squared. Okay, 1 plus cotangent. Let's see, 1 plus cotangent can be rewritten as cosecant squared. And then it's times. We need to show that that equals 1. Okay, so now cosecant. Well, cosecant can be rewritten as 1 over sine. Same thing if those were squared. So sine squared times 1 over sine squared. Does that equal 1? Yes, it does. So these would cancel, and 1 over 1 equals 1. Boom. Okay, the next one, we have to prove that cosine times tangent plus cotangent equals cosecant. Okay, so nothing is squared right now, so I'm not going to use any of the Pythagorean identities. Let's see, I could rewrite tangent and cotangent like this. Let's see what happens. So cosine of theta times tangent is sine over cosine. And then cotangent is cosine over sine. All right, so what would happen if I distribute this in? Let's see, if I distribute to the first one, that the cosines will cancel. So I'm left with just sine theta. But when I distribute to the second one, I would have cosine squared theta over sine. Okay, what could I do next? I could try to combine these, which means I would need to get a common denominator. So I would have to multiply top and bottom by sine theta. So then I will have sine squared plus cosine squared over sine. And sine squared plus cosine squared, that's the Pythagorean identity. That is 1. So I have 1 over sine theta. Well, what is 1 over sine theta? It equals cosecant, which is what I wanted it to equal. So manipulating all and changing these trig identities, you can then prove that this statement is true. All right, here's the last example we will do in the video, and then we're going to practice all different kinds in class. Okay, so what's funny about this example is I did this on paper before starting the video, and it took me 5 steps to get the answer. And then as I was doing the starting this video, I realized, oh my gosh, I could have got it done in 2 steps. So there's not always this single way to do all these problems. We can go about them different ways. Some people can prove them in less steps than others, but as long as you can prove it, then you're good. So let's see, if I have both of these being divided, you can divide both of them. So cosecant squared divided by cosecant squared is 1, and then minus 1 over cosecant squared. Well, what is 1 over cosecant squared? That would be 1 over, sine squared. 1 over cosecant squared would be sine squared. So 1 minus sine squared, well, that is right here, that 1 minus sine squared equals cosine squared. So there we have it. It's proved. Some of you will get frustrated with these, and that's okay, but they are kind of fun. It's just like a little puzzle we have to solve, and we'll learn some other methods in doing these. Good luck with the lesson.